Hello and welcome to my YouTube channel. So this is we can say an episode one where I'm going to explain some points of the deep learning. So my workout हो चुका है. I think मैंने workout आज किया था 10 से 11 बजे तक. Then I just made my smoothie. It's about uh, 35 grams of protein, and after that I'm just heading towards my classes. So अभी मेरा next class है 4 बजे, and 4 से 5 I have one data science, then 7 to 8 I have one batch, and then I have 8:30 to 9:30 one GenAI batch. So today's topic I'm going to teach in my class, which is called as deep learning. And like today I'm going to start as a day one of deep learning because after some time I will go for NLP. So I will take a good part of NLP in my data science, and then I will continue with you for the Gen AI batches where we need to go on the prompts. Some like काफी चीजें देखेंगे, like we have RAGs, we have agentic AI, we have like again the frameworks like LangChain and the LangGraph that we will cover. So today, as my batch is going for the deep learning, let's see how the deep learning it is and how it works on the data. So this is, if you see here, we have the structure here, like where we can see we have three inputs which are input one. Let me just try to get in it. Where we have the three inputs. Yeah, so where we have the three inputs, like if I just show you input one, input two, and the input three. So we have basically the three inputs inside this layer. And if you see, yeah, so we have the three inputs layer, and from here the data will be passed on for the next layer. So next layer we have something like a hidden layer, right? And hidden layer, and here the data will be passed on. So let's see how the things working inside this network. So once we get inside this network, we can see we have some structure where we can see a blue circles, a green one, and just we can see a purple one, just a light weight. So here, let's go in it and let's see how it is working. Now, if you see, so let's walk through like how like propagation works in a simple neural network. So this is we can say a neural network. Okay, and imagine we have three inputs. Like we have the three inputs. We have study hours, we have like sleep hours, and we have hours play. Like we have a student like who have this syllabus, and from that we are going to say like is it going to pass or like he is going to fail. Okay, now if you see, so these three features are labeled at, like we can say x1, x2, and the x3. So these are the three features we have. So now when the inputs enter in the hidden neuron, so we can see these inputs are entering into the hidden layer. So here, like in this way, in this position, and this layer is called as a hidden layer. So here we have a one hidden layer, and we have one something like activation function. Right now, when the inputs enter in the hidden neuron, each one gets multiplied by its weights. So we have weights you can see here. So how this calculation will look like? So we can say we are going to predict something like y. So this is our y. We want to predict that person will get pass or the fail. So to get that, we need something input. So what input we are providing here? We can say y equal to, we are saying w1 multiplied, we can say x1, right? Again, I'm doing plus. So this one we are doing w1 and multiply x1. We did plus. Then what we doing? We're doing w2 multiply x2. Then plus. So we just did this one, right? We did multiply, and then we go for w3 multiply x3. So this is, and we are adding a bias here. So bias is like never keep the zero input, even if we get input zero from the x, still if we have some bias, the bias will be changed. It's not constant. It is like a small value, so which will not allow the zero input for the next layer. So it will try to add some values. It's like suppose you have where something you're doing some x value might be we can say a zero value, right? So here, so we can see we are passing only zero for the next layer. So to avoid that, we are adding some bias. So because of bias, we will add something value for this activation function. Right? See, what is the activation function right now? Now the neuron applies on the activation function, right? So now let's see. Now what we're doing, we are adding some activation function for these neurons, right? Let's see how that activation function gets added. applied on the neuron. So it is live. Now the neurons applies an activation function. So here we are applying an activation functions on the neuron which we have right now. And in this example, we are using ReLU and we can say a rectifier denodulated. So here we are using an activation known as a ReLU. We will get to know about what is ReLU and what are other activation functions, how to work on the inputs of the neurons, we can say. And then, so here it says if the value is positive. So we are getting some calculation which is x and the weights, right? We are doing calculation of inputs with the weights, and what it's saying, it is saying simply if the value is positive, keep it. If it's negative, turn it into zero. This introduces non-linearity which allows the network to learn complex pattern instead of just a straight line. So we need to work on the patterns. Like no matter if you're just getting the straight line, we wanted to make it optimize and just make it done. So for that, the activation function is helping the input to getting done. It is like suppose you are just we have a torch, right? And the torch we have an option. And if I wanted just a small light, a dim light, I can just reduce that. So the we can say the light which is flashing ahead, so that can make it control. Suppose if I'm just into the forest and I just wanted to use just with the strong, like just strong, we can say the light, I can just change that position and I might get a good visibility. So I'm controlling the light with the scenarios. So here, if the model thinks, and if the like our deep learning model thinks that our how we should react on the given x and on the given way, so this activation function is activate that neuron and able to run the patterns and providing the output for the next layer. So once the calculation done here, now the value is going for to the next layer, right? The activated value is like a cell, we can say a set. We are just saying, which is we are doing a calculation here. Then pass forward to the output neuron. So this is the neuron we have, which are going to decide what our output will be. The output neuron again applies a weighted sum. Like we can see again we have some weights here. We will have some weights here. Again it will just get update here and add for the next output layer. And here like applied weighted sum adds its bias and finally uses a sigma function. A sigma like function like squashes between 0 and 1, which is perfect for the probability. So here in the end, we are getting one line, which is like squashes the line. And here we are getting one threshold, which we can say zero point 0.5. And here we are getting output within 0 and 1. Suppose if we are getting output as here we get as 86, we can say it is going for 1. If we are getting value below 0.5, we can say it will go for the 0. If you see how it working in the actual way, if I just get into the we can say into the animation, if you see in the animation, let's see how it is working. If we get for this time, let me just try to get back here. Now you can see first we need to add on our neurons. So as we can say as inputs, and on the inputs weights are getting applied automatically. Let's get here. Now we have added the weights, and now going ahead, the weights get added with the input, and now the input and the weights are getting calculated using the activation function. So the activation function we have the name as a ReLU. The same we have more activation functions like we have a leaky ReLU, we have tanh. We will see into the next video what are those and how they work. And then after get applied the activation function on our inputs and on the weights, now it will going to forward on to the next step, which is the output layer. In the output layer, we have a sigma function which will provide us the output between 0 and 1. It's best for the binary classification. It can be pass fail, it can be spam or not spam, not spam, and it can be like profit or loss like that. Again, if you see the next, now the activation function is applied, and here we can see it is just going next for the output layer, and we are getting an output. So here in this case we got something around like 0.86 might be. So it's depend on that given statement what you are passing the input and what output you are looking for. Again we have more we can say functions into the output layer where we can decide so there we should needed the two outputs or we need like, and we're looking just for a numerical one way, or we're looking for the multi pass. So we can say, so that time we can use a different type of function here. So this is for today's session, and I'm sorry for my rate of speech because it might just a teaching video on the YouTube. And in the coming time, like for the tomorrow, I will pick the one thing which is much important as a backward propagation. So this was a complete forward propagation where we are passing all the inputs and the outputs into the forward direction. So tomorrow again we will just revise the same thing which we done today, and tomorrow we'll get back on the backward propagation where we're simply adding the weights and bias, and we are working on the complete epoch of one deep learning, and we will know how deep learning are learning the patterns and able to predict the like much better way. And thank you for watching this video, and we'll get back tomorrow with the same time, and keep learning and keep doing workout. Bye bye.